matter POGIL. As always, we see the model, try to figure out what we're looking at here. And the first thing you're going to do is just from this picture, you're going to look and fill out this table. So for spacing, we're talking about the particles here. So you're going to look at a solid, describe the spacing of these particles, write it here. For the liquid spacing, you're going to put it here. The spacing of the gas particles, put it there. Potential for movement. How much movement can those solids have spaced as they are? So basically you're going to put a little, virtually none, or a lot. And you'll do the same for liquid here, gas here. And then this is simply yes or no. Will it fill a container that it's put in? So you'll have yes or no in each of those boxes there. Once you fill that out, it says 2, in which state of matter is there the least spacing? So just go back to your picture, look which particles are the closest together, and then tell me if that was the gas, liquid, or solid for 2. 3 says, in which state of matter is there the most potential for movement? So again, you're just looking at your chart here. Which one did you put has the most? Or if you didn't put most and you just described it, look up here and put one of those states of matter, gas, solid, or liquid. 4 says, which state of matter does not have a definite shape, yet the particles will not fill a container? So again, look at the picture. You're looking for ones that don't have a definite shape and won't fill a container. 5, in terms of spacing, what needs to happen if you're going from a solid to a liquid? In other words, are they going to become more spaced out, get closer together? And what's this process called? What happens when we're talking about energy? Are we absorbing or releasing energy? And if you know the name, melting, freezing, condensation, evaporation, that would be great to put here too. But as long as you put absorbing or releasing heat, and if it's getting more spacing or less, that's fine. Same thing for 6, except this time going from a liquid to gas. And same thing for 7, except going from a liquid to a solid. So for each answer, you're going to describe what's happening, spacing, getting more spread out or closer together, if you're absorbing or releasing energy. And if you're getting good at your vocab, you can put the term like freezing, melting, condensation, those things. Once you finish that, you're going to look at this next diagram. Make sure you read the background for phase changes. And this picture puts some terms in if you weren't familiar with them yet. Question 1 says, list 3 states of matter in order from least energetic to most energetic. So if you don't know that, this picture doesn't necessarily do a great job of showing that, but this picture should, if you remember that the more particles spread out, the more energy they have. So question 1 down here, you're going to put least amount of energy, middle, and most for solid, liquids, and gases. Which of these phase changes will result in a release of energy? So use your words. Melting, freezing, condensation, boiling, sublimation, deposition. Which of those are going to give off energy? If you don't remember, you give off energy when you are slowing down. So the molecules are getting closer together. 3 should be the rest of those terms, of these 6 terms up here. Which of these need energy? Well, you need energy if you're going to make the molecules move faster and spread out. Of those 6 answers up there, which would be warming or heating up, and which would be cooling? And then you're going to use this diagram only to fill out this table, and that gives you some examples. In condensation, it says energy is released. How did they get that? Well, it says condensation is going from the fast-moving, spread-out particles in a gas to slower-moving and less spread-out liquid. So when we're going this way, we are releasing. If we're going this way in this chart, we'd be absorbing heat. So that'll help you fill out this column. In the change of state, if we look at evaporation, it says liquid to gas. How do we find that answer? We start at liquid. We follow the arrow going to a gas. So our answer is either boiling or vaporization. I'm sorry, for evaporation, it was liquid to gas. So I actually was kind of showing you where to find it. But if we wanted to find the term, we would find evaporation, which is just another way of saying vaporization. And we would just follow that liquid to gas like they did. Once you fill out that, this last thing is just definitions. Use the changes of state terms. Practice our definitions. Look at your notes or the diagram up there, and you're just going to put the letter. If this is sublimation, you're going to put A here, B, or you could even copy and paste. Notice there's more definitions up here than there are terms, so each of these can be used more than once.